Welcome to Owie and Sandy Math Along. I'm Sandy.
And I'm Owie. You shut up here.
Hello, my first tutoring request came from a calculus student. After speaking with the teacher, I found out they're doing something similar in pre-calc and calc. So this question is actually for both. Similar question, not identical to the one given in class, of course. We want to find the holes in the graph, okay, of this function, and find the discontinuities. So pre-calc holes, calculus discontinuity. Looking at this function, what we want to do is figure out our domain for x. The domain tells us where we will have those holes, gaps, asymptotes, whatever you'd like to call them, discontinuities. So the first thing we need to do, I want to go ahead and break apart my denominator so I can better understand what my domain is. Remember, domain has to do with what x cannot be. X cannot be anything that's going to make this denominator 0. That's where we will have those discontinuities. So we have same numerator. On the bottom, I actually have the difference of two squares. You should remember that back from algebra. I believe algebra 1 goes over the difference of two squares, and of course algebra 2. So now we have on our denominator x minus 2 and x plus 2. I notice, I'll use a different color, that I do have x plus 2 on the top and bottom. Since I have them on top and bottom, that's a removable discontinuity or a hole, okay? Now, it's not x equals 2 there. It's wherever x plus 2 equals 0, because that's what's going to force our denominator to be 0 and our function to be undefined. It doesn't exist where it's undefined. Okay, so at x plus 2 equals 0, x minus 2, we have removable discontinuity, aka a hole. Okay, so pre-calc, you have a hole there. Calculus, you have a removable discontinuity there. Okay? Over here we have x minus 2 equals 0. Now we don't have that top and bottom, we just have it on the bottom. There's going to be something happening in our graph there because it's going to be undefined function there. That means that x equals 2. We have an infinite discontinuity, hole, infinite discontinuity, and removable discontinuity. Remember on the graph, a vertical asymptote. I'm going to make a fake graph. Hopefully you can see it. Let's see, it's 2. Looks like that, okay? And the graph can't touch it. A removable discontinuity, it looks like a hole. So let's say it's a negative 2. Our graph looks something like this. You would have a hole at x equals negative 2. Hope this helped. If you have any more questions, please put them in the comments. If you come to my school, then you're welcome to stop by my room or talk to your teacher, of course. Thank you.